I'm Riley,
Isley.
and this is our review of Chapter
3. Of Chapter 3.
For this section, we're going to be reviewing transversals and proving lines parallel. So for transversals, some common terms we're going to need to know are interior angles, which are angles that are inside the two parallel lines, or the two lines that the transversal cuts through. Exterior angles, which are the angles on the outside of the two lines that the transversal cuts through. Consecutive interior angles, which are angles on the same line, with the transversal splitting them. Alternate interior angles, angles that are alternating on either side of the transversal on the interior of the two lines. Right here we have the examples for each of these terms. Alternate exterior angles, which are angles alternating on the sides of the transversal but on the exterior of the two lines. And corresponding angles, which are angles that are equal and on the same side of each of these lines. So for an example, angle 5 and angle 1 would be corresponding angles because they're both on the same side of each line they're on. 4 and 8 would be corresponding because they are also on the same side of each line they're on. Next we have the corresponding angles postulate, which states if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So, here's this diagram. If P and Q are parallel and they're cut by a transversal, all these corresponding angles are congruent. Next we have the perpendicular transversal theorem, which states in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. An example is if P and Q are parallel lines and Q is perpendicular to T, then P is also perpendicular to T. Next we have proving lines parallel. So, a term you're going to see a lot here is converse, which just means the opposite of, or not necessarily the opposite, but just pertaining to lines instead of angles. So the converse of corresponding angles postulate states that if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel, which is the converse of the corresponding angles postulate, which states if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So it's the converse. And then you use that same reasoning to state and explain these other postulates. So first we have the alternate exterior converse, which just means if two lines are cut, or if two lines are cut by transversal so that alternate exterior angles are congruent, then the lines are parallel. And same with the consecutive interior angles. So if two lines are cut by a transversal so that consecutive interior angles are congruent, then the lines are parallel. And then same with alternate interior angles, perpendicular transversals. So if two lines are cut so that the angles formed create a 90-degree angle, then the two lines are parallel and the transversal is perpendicular to the two lines.
So today we're going to learn about lesson 3-3, slopes of lines. The most important thing you have to know for this is the equation for slope, which is the change of x over the change in y, or y2 minus y1 over x2 minus x1. To find the slope, you need 2 points, and in this case we're using -2, 3 and 1, -3. So you're going to want to plug in those points into this equation. You get -3, -2 for the x coordinates and 1, 3 for the y coordinates. And ultimately you will get 1 minus 3 over -3 plus 2 equals -2 over -1, or just +2. Positive slopes will always be slanting like this, negative slopes will always be slanting like this, and slopes that are 0 are going to be horizontal, and undefined slopes, so like 1 over 0, are going to be vertical lines. Perpendicular lines have a negative opposite slope. So a line perpendicular to a line with the slope 1/2 is -2. Parallel lines have the same slope, so a line parallel to a line with the slope 3/4 is just going to be 3/4. Alright, so the second lesson we're learning is 3-4 equations of lines. We're going to be learning the slope-intercept form and point-slope form. The slope-intercept form is y equals mx plus b, where m is slope and b is the y-intercept. And point-slope form is y minus y1 equals the slope times the quantity of x minus x1. For slope-intercept form, if you have a slope 4 and y-intercept -3, you're just going to plug in 4 to m, so you're going to get y equals 4x, and then the y-intercept, which is -3, minus 3. And then the line here is going to be a positive line, like slanting this way, because the slope is positive. An example for point slope is if the slope is 1/2 and the point is 3, 1, you would plug in y minus 1, which is this point, because it's y minus y1, and then 1/2 because you plug in the slope for m here, and then x minus 3 because the point is 3. These two equations, y equals 2x plus 3 and y equals 2x plus 7, are parallel because these two slopes are the same. The y-intercepts don't matter. These two equations, y equals 2x plus 3 and y equals -1/2 x plus 7, are perpendicular because the slopes are negative opposites.
Hola! Today we will be discussing how to find the distance between parallel lines. Let's begin. How to find the distance between parallel lines. There are only 3 basic steps to solving this. But always, before you start, always draw the equations of your lines on your graph and make a straight line from line M to line M. And we'll call that line P. The equations of your two lines are y equals 2x plus 1, that's L, and y equals 2x minus 3, which is M. Okay, for step 1, we're going to write an equation of line P. The slope of P is the opposite reciprocal of 2, or -1/2. Use the y-intercept of line M, 0, -3, as one of the endpoints of the perpendicular segments. So first, here as you can see, we're going to use slope-intercept form, and then we're going to plug in our numbers for where they correspond to, and we're going to simplify. We are going to use a system of equations to determine the point of intersection of lines L and P. Here are our two lines of L and P, and we are going to make L equal to P, and then we're going to group like terms on each side, simplify on each side, multiply on each side, and then substitute for -8/5 for x in the equation for P, and we're going to simplify and we'll get a -11/5. Okay, the last step is the easiest step. All we're going to use is the distance formula, which is right here. We're going to use the distance formula to determine the distance between points 0, -3 and points -1.6 and -2.2, which we had figured out. So we're going to plug all those numbers in right here and simplify using a calculator, and we get 1.8. This is the distance between the lines. It's about 1.8 units, and this is the correct answer. Kobe!
That wasn't good.
Yeah, that was good.